Hello friends, myself R.D. Mahajan presenting my video on courtesy polar type part 4th. Example, trace the curve r is equal to a into cos of 3 theta with full justification. As the equation is in terms of r and theta, it is called as a polar curve. Then to trace any polar curve, we follow this procedure. Point number 1, symmetry. Replace theta by minus theta in the equation, and if no change, then curve is symmetrical about initial line, and therefore cos of minus theta is cos theta, means no change, therefore curve is symmetrical about initial line, means line theta equal to 0, and no any other symmetry exists here, only it is symmetrical about initial line. Then the second point, tangent at the pole. Substitute r is equal to 0. Therefore, put r is equal to 0, we get 0 is equal to a into cos of 3 theta. Dividing by a, we get cos 3 theta is equal to 0. 3 theta is equal to cos inverse of 0. Cos inverse 0 plus minus pi by 2. And therefore we get theta is equal to plus minus pi by 6. These two lines as a tangent, two different tangents at that point, and that's why we get a node point. Then next one is a table. Then we make a table for the different values of theta ranging from 0 to pi, as 0, pi by 6, 30, pi by 3, 60, pi by 2, 90, 2 pi by 3, 120, 5 pi by 6, and pi 180 degree. And therefore, substituting this value here in the equation, cos 0 is 1, therefore a, cos of 3 times pi by 6, it becomes cos of pi by 2, and the value of cos pi by 2 is 0. Then cos of 3 times pi by 3, it becomes cos of pi, and the value of cos pi is minus 1, and therefore that point becomes minus 3. Then cos of 3 times pi by 2, it is 0. Then cos of 3 times 2 pi by 3, 3 get cancelled, it is cos of 2 pi, and the value of cos 2 pi is 1, and therefore it is a. Cos of 3 times 5 pi by 6, 3 to the 6, it becomes 5 pi by 2, and the value of cos 5 pi by 2 is 0. And lastly, cos of 3 pi, odd multiple of pi, value is minus 1, and therefore that point is minus 3. And therefore the point which we have to draw is r theta. R is a, theta is 0 degree, then 0, pi by 6, then minus a, pi by 3, 0, pi by 2, a, 2 pi by 3, is 0, 5 pi by 6, and the last one is minus a pi. Then the fourth and last point, we require to find the value of tan phi. Therefore fourth point is tan phi, where phi is the angle between radius vector and tangent, is given by r divided by dr by d theta. And then r is a into cos of 3 theta, Differentiating it with respect to theta, a derivative of cos is minus sine of 3 theta chain rule into 3. Therefore, a cancel, we get that value as minus 1 by 3 cos by sine, it is cot of 3 theta. Then we require to find this tan phi for that theta having maximum value for r. Here the maximum value is a minus a and therefore when we substitute theta is 0 here, it is cos 0 by sine 0. For theta is equal to 0, we get that tan phi as minus 1 by 3 cos 0 upon sine 0. Cos 0 is 1 and sine 0 is 0. 1 by 0 is infinity. Therefore, that is infinity. Neglecting that minus sign. And therefore, phi is equal to tan inverse of infinity. The value of tan inverse of infinity is pi by 2. Means the tangent is perpendicular to this radius vector for theta is equal to 0. Therefore, it is perpendicular to the radius vector. This pi by 3 means for theta is equals to pi by 3, theta is equals to 2 pi by 3 and theta is equal to pi. We get the same. Tangent is perpendicular to that radius vector. And then after discussing all this, we have to complete the figure. Then draw this type of line. Theta equal to 0, pi by 6, pi by 3, theta equal to pi by 2, theta is equal to 2 pi by 3, theta is equal to 5 pi by 6 and theta equal to pi. If the value of r measured positive, we plot it in upper part, and if r measured negative, we plot it in the lower part of that figure as per the procedure. And the first step, draw the tangent at the pole. Pole means origin. This one is the pole. The tangents are theta equal to plus pi by 6 and theta equal to minus pi by 6. And another tangent is theta equal to minus pi by 6, means 5 pi by 6. Okay. What the points? The first one is A0. Distance from the pole is A and it lies on the line theta equal to 0. Therefore, approximately if we take this much distance as A and angle made by that line is 0 degree with initial line, and therefore point lies on that initial line. Then second point, 0 pi by 6. R is 0, radius vector length is 0 for the line theta equal to pi by 6. Therefore, on that line we draw this point. It is on the pole. We have to join this smoothly, knowing the fact that this line is a tangent. Therefore, it will touch in the origin only or in the pole only, and therefore we make it at the for theta equal to 0. That tangent is perpendicular to this radius vector, and therefore we make a perpendicular tangent. And due to this perpendicular tangent, the shape of the curve is a slightly parabolic. Therefore, we draw a slightly parabolic part. A single point of contact at this point. Then this parabolic part we have to join to this pole, knowing the fact that this line is a tangent, means it should not cross anywhere. That line, then and only it becomes a tangent. Therefore, I will join this smoothly. We get this part. Symmetry is about initial line, therefore have a symmetrical portion about initial line. We get the first loop. Then for theta equal to pi by 3, the value is minus a. Therefore, on that line, as the value is negative, we plot it in lower portion. Same distance, approximately this. Then for pi by 2, once again 0. Therefore, from this to this and this to this. Once again, for theta equal to pi by 3, the tangent is perpendicular to that radius vector. Therefore, we make a perpendicular tangent. And due to this perpendicular tangent, the shape of the curve is slightly parabolic. Therefore, once again, I will show a slightly parabolic part here. Therefore, this pole to this and this next point, for pi by 2, we get 0. Once again, we are getting the point pole at pole. Therefore, pole to this and this to again pole. We have to join very smoothly. Second loop of that curve. Then the remaining points. For 2 pi by 3, value is a. Therefore, on that line theta equals to 2 pi by 3, distance from the pole is a. Approximately, we make that distance as a, suppose. For 5 pi by 6, once again it is 0. And for pi, it is minus a. This is the positive direction. Negative direction is theta equal to 0 degree. And therefore, from pole to this and from this to pole. For theta equal to 2 pi by 3, once again tangent is perpendicular to the radius vector. Therefore, we make a perpendicular tangent. The angle between tangent and radius vector is phi. That phi is here pi by 2. Then I will complete here slightly parabolic part. This parabolic part we have to join to pole, and this part we have to join to pole, and therefore we get 3 loops. And there is one property for this type of curve: r is equal to a cos n theta or r is equal to a sin n theta. If n is odd, there are n loops only. Here the value of n is 3, odd number, and therefore we get 3 loops. End of figure. Therefore, this is the figure representing that curve r is equal to a cos of 3 theta. If you like my video, please share it, as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you. Thanks for watching.